Hello everyone, I'm Pragati Srivastav Dev. In this lecture, I'm going to discuss about the types of transfer functions and its representation. So let's start with the transfer function. So transfer function gives the relationship between input and output of a system. So its proper definition is the ratio of the Laplace transform of the output to the Laplace transform of the input under the assumption of zero initial condition. So here, while writing the definition or while learning the definition, always remember one thing, that in transfer function, we have to assume zero initial condition. And always we are taking output and input in Laplace transform form, right? Normally, students are, if we ask about the definition of transfer function to the students, they said it is the relationship between input and output. No, it is not the right definition. Always we have to say it is the ratio of Laplace transform of the output. This Laplace transform of the output, this is the important thing, and Laplace transform of the input. This we have to remember. And in transfer function, we have to assume zero initial condition. So this is the definition of the transfer function. Now, there are two types of transfer function. There are two types of systems. One is the open loop system, another one is the closed loop system, right? So the first we'll see the transfer function of the open loop system. So how we can represent the transfer function of open loop system? So this is the standard representation of the system. So I have considered here one block. This block, this G1S, this G1S is the total gain of the system. U1S is the input signal given to the system, and Y1S is the output which we are getting from the system. So how we can write the transfer function for this open loop function? Output upon input. Both the values I have taken in S domain, that is Laplace domain. So I have written here U1S, here Y1S. So the transfer function we will write as transfer function is equal to Y1S. Just see, transfer function is equal to Y1S, output upon input, that is U1S, right? Which is equal to what? That is G1S. That is the overall gain. So we can also said that transfer function is the overall gain of the system, that is G1S, right? This thing I can write in this form also. That is U1S multiply by G1S, means input signal multiply by the gain of this box will give you the output value, that is Y1S. Right. Again, I can write Y1S upon U1S is equal to G1S, which I have written here also. Right. So this is the transfer function of the open loop system. Now next, the types of closed loop transfer function. So there are in closed loop system, two types of transfer functions are there. First one is the positive feedback control system. Another one is the negative feedback control, right? So types of feedback control are of positive feedback control and the negative feedback control. Now first understand what is the positive feedback control. The output signal is fed back so that it adds to the input signal, will called as positive feedback control. So again, from this diagram, I can explain you, this is the closed loop system, right? This is the closed loop system representation of the block diagram. This is the standard representation of the closed loop system, right? Here, GS is the forward path gain. Here, HS is the feedback path gain. Input, we are representing here by RS. Output, we are representing here by YS. Input is RS. Now, this is the summation point. This one is the summation point. This circle is also called as error detector. So this circle, we can represent it by summation point, or we can say it is a error detector. So at this summation point, two signals are coming. One is the input signal and one signal which is the output signal which we are fetching and taking towards this summation point. Just look at here. This output signal, that is YS, we have fetched from this point, right? And this YS with the gain HS we have given to the summation point, and that signal is called as BS. And this signal is called as feedback signal. So the summation of these two signals, that is input signal and the feedback signal. Why I am saying summation? This summation point will take the algebraic sum, right? So for that purpose, we have to see the sign over here. So here input is given with the positive sign and output is also fed by the positive sign. So this EAS, whatever the error signal, this EAS is called as the error signal. This error signal will be generated as RS plus BS, right? So EAS will become RS plus BS. RS plus BS, right? So this, suppose we are feeding the output as a feedback to this summation point with positive sign. So this type of closed loop system will become positive feedback closed loop system, right? Now come to the second diagram. Now this is the block diagram of the negative feedback closed loop system. Standard representation of the negative feedback closed loop system. Now again in this also, everything whatever we have seen here, the same thing we are seeing here also. Input signal is given, which is represented by RS with positive sign. We are feeding this signal to the summation point. Now EAS is the error signal, GS is the forward path gain. Output here we are generating with YS. Then YS we have taken from here. This point is called as takeoff point. We have taken this output from here and we are just giving to the, or we can say we are feeding to the summation point with the negative sign, right? So YS we have taken, multiplied by HS, we will get the feedback signal BS. With the negative sign, we are giving to the summation point. So in this case, EAS will become RS minus BS. It will become RS minus BS, right? So that's why here the feedback signal is with the negative sign. Therefore, this block diagram, we can say that it is a negative feedback control system, right? So in this slide, we have seen two types of feedback control. One is the positive feedback control, another one is the negative feedback control. So always remember one thing, the feedback signal is having positive sign, then it will become positive feedback control system. And if it is having negative sign, then it will be said to be as negative feedback control system. Now, let's start with the negative feedback closed loop system. So I have considered here one, this is the closed loop system diagram, block diagram. So now we have to find out the transfer function for this negative feedback closed loop system, right? So what we have learned, transfer function is nothing but, transfer function is represented by, suppose TS is nothing but output upon input, which is equal to, here we have represented output by YS and input by RS. So we will write here YS upon RS. This is the transfer function. Now we want to solve this loop to get the overall gain of this system, to get the overall gain of this system. So here directly I have written the expression that for this, first just see, Here I have given the negative sign. That's why it is a negative feedback closed loop system. So I want the total gain of this system. Means we have to solve this complete loop, right? So the expression of this loop we will get here GS upon 1 plus GSHS. So this is the transfer function of this negative feedback closed loop system. So now in the next slide, we have to derive this expression. So let's start the derivation of the negative feedback closed loop system. Just look at this diagram. How we will proceed to get this expression. Our aim is to get this expression of the transfer function of negative feedback system, right? So we will start with this. What is ES? EAS? EAS is the error signal. So EAS, we can say that RS having positive sign, BS is having negative sign. So we will write here EAS is equal to RS minus BS. So this is the first equation we have written, right? Then, now what is BS? BS means this signal, feedback signal. This feedback signal is the product of HS into YS. So BS is nothing but HS into YS, that is feedback gain multiplied by output signal. So I can write BS as HS into YS. So I have written in second equation, BS I have represented here by HS into YS. Right, so we got the second equation. Now we have to see what is YS. Now just see YS. YS is nothing but this is your YS, that is the output signal. So we can say YS is nothing but GS into EAS, that is the error signal. So YS output signal is the multiplication of forward path gain, that is GS, multiplied by the error signal EAS. So I have written here YS is equal to GS into EAS. Now ultimately I want YS upon RS, right? So for this, here, what we'll do, I want this second equation, whole second equation in terms of RS, HS, YS. So instead of EAS, here I will substitute EAS with YS upon GS. From the third equation, we can say EAS is nothing but YS upon GS. So in second equation, I will substitute in place of EAS, I will write down YS upon GS. So we will get this fourth equation. That is YS is equal to GS RS minus HS into YS. Right, now take this expression. Now we are getting here, I am writing this YS is equal to, now I'm taking this GS inside the bracket. So GS multiply by RS minus GS multiply by HS into YS. So this I'm getting. Now what we have to do, this YS is there. Now take this expression, this equation on the left hand side. So we will get here YS plus GS HS into YS, which is equal to GS into RS. GS into RS, right? Now, this YS and this YS we have to take as common, right? So, we will get this equation. YS I have taken common. In bracket, we will get 1 plus GSHS, which is equal to GS into RS, right? Now, just rearrange this equation in terms of YS upon RS, because YS is the output signal, RS is the input signal. So if we write YS upon RS, so we will get here YS upon RS is equal to GS upon 1 plus GSHS. So in this way, we have derived the transfer function of the negative feedback system, right? Again, I am repeating how we have to proceed for this derivation. first we have to consider the expression of EAS. Now, what is EAS? It is the algebraic sum of input signal and the feedback signal. Input signal is RS, BS is the feedback signal. So we will write here ES as RS minus BS. Then BAS we will substitute by HS into YS. Then YS we will consider as GS into EAS. Now just we have to, by using these three equations, we have to form the expression of the transfer function of closed loop system. Right, so this is the transfer function of the closed loop system, and students, you have to remember this expression for further studies. Means after this we will study the block diagram reduction technique to determine the transfer function of any given system. So for all those things, then we will see the signal flow graph further. So for all these methods we require the transfer functions. So always we have to resolve this loop. While doing the block diagram reduction technique, we have to resolve these loops. So we will directly, for resolving this loop, we will directly use this expression GS upon 1 plus GSHS, right? So you have to remember this expression GS upon 1 plus GSHS for the negative feedback system. One thing you remember, for negative feedback, always in the expression of transfer function, you will get in the denominator positive sign, right? Now we will see the expression in terms of error signal. Suppose I want the formula for error signal. So how we will proceed? Just see. EAS is the error signal. Again, I have taken the negative feedback system. In this negative feedback system, we are just deriving the formula for error signal. So here, again, we will start with the same method. EAS is the summation of RS and BS. So RS is having positive sign, BS is having negative sign. So we will write here EAS is equal to RS minus BS. Now EAS is equal to RS minus, what we will substitute here in place of BS? BS is this product of HS into YS. So we will substitute here BS as HS into YS. Now, what is YS? YS is nothing but GS into EAS. So here I have written GS into ES. Again, these three equations are same, which I have written to while deriving the transfer function of negative feedback system in the previous slide, right? Now here I want the expression in terms of EAS. So what we will do here? In this equation, we will substitute in place of YS, we will substitute GS into EAS. Means we are making this whole equation in terms of EAS, RS and HS. So in place of YS, we will substitute here GS into EAS. So we'll get this equation. Now, just multiply this thing. EAS is equal to RS minus HS, and in place of YS, I have written GS into ES. Now, this whole expression we will take on the left-hand side. So we'll get this equation. Just take this equation. After substituting the value of YS here, just take this expression on the left-hand side and you will get this equation, right? So now EAS is nothing but RS upon 1 plus GSHS. So this I've written in terms of error signal EAS. Now moving forward, now we have to see the derivation of transfer function for positive feedback closed loop system, right? So for this, again, we have considered this transfer function block diagram. This is the closed loop block diagram of the positive feedback system. Why I'm saying positive feedback? Because positive sign is there. The sign of the feedback is positive. That's why it is called as a positive feedback closed loop system. So now again, we have to derive the expression for transfer function of closed loop system, which is having positive feedback. Now again, start with the same expression. Consider EAS, which is equal to RS plus BS. Now here we have to write down, instead of minus, we will write down plus over here, because the feedback signal is having positive sign. Now again, substitute BS as the product of HS into YS. So I have written here BS as HS into YS. Now just take this YS. This YS is nothing but GS into EAS. So I have written here GS into EAS. This output signal is the product of forward path gain multiplied by the error signal. So I have written here YS is equal to GS into EAS. Now just substitute. Now we want the expression in terms of YS upon RS. So we want to replace something here with EAS, right? So here what we'll do, EAS is equal to what? YS upon GS. That will substitute here, right? So after substituting in place of EAS, GS upon YS upon GS, we will get this expression. Now just multiply this GS under the bracket. You will get GS into RS plus GS into HS into YS. Now just take this expression on the left hand side. You will get and take YS as common. So you will get this expression. Now just arrange this equation in terms of output upon input. So here output is YS and input is RS. So just take the ratio of YS upon RS, we will get here GS upon 1 minus GSHS. So this is the expression of negative feedback. This is the expression of positive feedback closed loop system. So students, you have to remember this thing. This expression we have to remember. Suppose if this closed loop system is having positive value, so we will write down, directly we will write down the expression YS upon GS as this thing. You just see what I have done. I have solved this loop basically. I have derived the expression of transfer function. Means what? I have solved this complete positive feedback loop. So this whole diagram will be simplified in this form. Let's see. This is your RS input signal. This is YS. And under this loop I have solved, right? By using these equations, I have derived the expression of the transfer function. Means I have with this we have found the complete gain of this block, this closed loop, right? So that this whole closed loop I will represent it by a single block having a gain of GS upon 1 minus GS into HS. So this whole loop I have replaced by a single block with the expression GS upon 1 minus GS HS, which is nothing but the overall gain of the system. That is YS upon RS, which is nothing but the transfer function. So the transfer function of positive feedback system is GS upon 1 minus GS into HS. This you have to remember. Now again, for this positive feedback system, we have to find out the expression in terms of error signal. So again, we'll repeat the same process. EAS is equal to RS plus BS. This is the first equation. Now in place of BS, I have written BS is the product of HS into YS. So I have substituted in place of BS, HS into YS. Now, what is YS? YS is nothing but GS into EAS. So I have written here. Now just substitute. Now I don't want this YS. I want to replace this YS in terms of EAS. So what we'll do, in place of YS, we'll write down GS into EAS in this second equation. So we'll get this equation, right? Now just rearrange this equation. You will get this one. Now I want EAS. So EAS is nothing but RS upon 1 minus GSHS. This is the expression of error signal EAS for positive feedback system. So I hope you understood that how many types of transfer functions are there in closed loop system. One is the positive feedback, another one is the negative feedback. And then we have seen the expression of positive feedback transfer function and the negative feedback transfer function, and we have derived in this these expressions also in this lecture. Right, now come to the application part. Now, where we will use this positive feedback. So normally you will find out that positive feedback will used in oscillator circuits. This is the most common example of positive feedback system, and it is rarely used. So if anybody asked in your Viva, so always remember this thing, that positive feedback we are using for oscillator circuits. And for other circuits, mostly 90% of the circuits are using negative feedback, like amplifier circuits and many other control systems like motor control systems, etc. Right? So these are the applications of positive feedback and negative feedback element. These are the references I have used. So thank you so much.